All right, guys, this is chapter 1, section 4, angle pairs. We're going to talk about lots of different types of angle pairs and the relationships that they have. To warm things up, we're going to go ahead and review some of the things we learned about in chapter 4, in particular, naming angles. So go ahead and pause the video and answer this question. Name 4 angles in this picture. So I'm going to keep moving on, but go ahead and pause it so you can do this. All right, so I want to remind you guys a few of the different ways for us to name angles. So if we want to talk about, for instance, this angle right here, there are a couple different ways that we can do it. The easiest way would be to just call it angle 1, right? This symbol meaning our angle, and then we just use the number that's in there, and that refers only to this angle. Another way we can do it is to use the 3 letters that kind of define the sides and the vertex and the other side of our angle. So we could name this angle TQU. It's really important to remember that the vertex always has to be in the middle. So our vertex here is Q, that is the middle letter there. And then the other way, so we went TQU, we could go the other direction and call this angle UQT. One of the ways I like to think about it is with these 3-letter namings, I'm just sort of tracing the angle. If I follow the letters, I kind of trace the angle. So U, Q, T, and just following those lines, I make that angle. Again, we have other angles here. For this one, we could just call this angle 2, or we could call it SQR. That would be one other angle. Or RQS. Notice that all of the angles here have Q as a vertex, so we should never name any of them angle Q. That is real bad, because how in the world are we supposed to figure out which of these which of these many angles would be called angle Q? So we never want to call any of them angle Q. Q is their vertex, but speaking of many different angles here. All right, so I'm going to go ahead and move on into the content for this lesson, the different angle pairs that we have. So 2 angle pairs that exist are adjacent angles and linear pairs, and they're sort of related to one another. Adjacent angles, I like to think of adjacent angles as just being next to each other. It says there are 2 angles in the same plane, they're coplanar, with a common vertex. We can see the common vertex here, and a common side, so a side in between them. So these 2 angles, they're just next to each other, but they have no common interior point. So the interior of this angle is here, interior of this angle is here. And they don't have any overlap as far as the interiors of those angles go. So they have no common interior points. But if we kind of look here, they share a side. So they share the side in here, and they share a vertex. They're just next to each other. They're touching one another. A linear pair is a little bit different, only in one sense. They are adjacent. They're next to each other. You can see here they have a common vertex, and they're next to each other. They share a side, or they have a common side. A linear pair of angles is a pair of adjacent angles whose non-common sides are opposite rays. Now that's a little bit odd, but so right here, this side of angle 3 and this side of angle 4, we could think of them as rays going in exactly opposite directions. I like to think about them a little bit differently. I like to think of them as forming a straight line. That's where we get the word linear from. When we say linear pair, the 2 angles together form a straight line. And that leads us to our first theorem. So relating to the protractor postulate that we learned before, we know that a straight line has a measurement of 180 degrees, or 2 opposite rays make 180 degrees, and all of the angles in there can be put in a 1-to-1 correspondence with the numbers from 0 to 180, so from 0 degrees all the way over to 180 degrees. The linear pair theorem says if 2 angles form a linear pair, then they are supplementary. Supplementary is not really something we've gone over yet, but what we're saying is when we have a linear pair, the 2 angles have to add together to be 180 degrees. We'll actually prove this later on. All right, then we have our next set of angle pairs. We have things that are called complementary angles and supplementary angles. And these two angle relationships have to do with the two angles adding to a particular value. So complementary angles are two angles that add to be 90 degrees. So in this picture here, we have angle A and B are complementary because if we add their measurements, 30 degrees plus 53 degrees, we get 90 exactly. And so we would say that those two angles are complementary. Supplementary angles are two angles whose measures have a sum of 180 degrees. So angle A and angle C are supplementary because if we add their measurements, we get exactly 180 degrees. Those are relationships you've probably seen before, but want to formalize them here. All right. And then we have these two things called the complement and the supplement of an angle. You can always find the complement of an angle by subtracting the angle's measure from 90 degrees. So if some angle measures x degrees, then you can find its complement by doing 90 minus x. The point of a complement is if we have an angle and we want to know what angle would add to 90 with it, well, that angle that we're looking for is called the complement. And they have this specific relationship. If you know the measure, you can always find the complement. You can find the supplement of an angle by subtracting the angle's measure from 180 degrees. So an angle and its supplement will always add to 180. So if an angle measures x degrees, the supplement is going to be 180 minus x. Pretty easy to find out there. All right. So here we have an angle measurement here, and we're going to find the complement and the supplement of this particular angle. So we have a 42 degree angle. So to find the complement, we're going to do 90 minus 42. So the complement would be a 48 degree angle. Then we would know that those two angles together are complementary and they would add to 90. The supplement of this angle, we would take 180 minus this measurement. So we'd get 138 degrees. So the supplement of this angle is 138 degrees. And if we add those together, obviously, again, we get 180 degrees exactly. All right. And then our final angle pair to talk about are called vertical angles. Vertical angles are two non-adjacent angles formed by intersecting lines. Oops. So in this picture, non-adjacent meaning that they are not next to each other. They do share a common vertex because all of the angles here have this same vertex in the center, right? And I can actually draw that in there. So they all have this common vertex point right there. So they do have that in common, but the non-adjacent ones are not going to actually be touching each other's sides. So in this picture, we can see that angle 1 and 3 are vertical angles. They're exactly across from each other. And then 2 and 4 are also vertical angles. They're exactly across from each other. Oops. So they would be vertical angles. All right, here's our second theorem, the vertical angles theorem. So if two angles are vertical angles, then they are congruent. Now that's not something that we've really talked about, and it's based on our linear pair theorem here. We could prove this, but we're not quite ready to do that at this moment. So in this picture, we can see that we have a couple sets of vertical angles. We have this one here with EDF, and this one down here with GDH. Those would be considered vertical angles. And then we have our other angles, EDG, this one here, and FDH. These would also be vertical angles. And the theorem says that those angles are going to be congruent to one another. Again, this is not an idea that we know yet, but it is something that eventually we will be proving. You can see there the color coding. These two angles match these, and then these two here. And those are vertical angle pairs. Again, something that we're going to prove in the future, so something to look forward to. All right, so whenever you have intersecting lines, if you know one of the angle measurements, you should be able to find all of the other ones based on those two theorems that we just talked about, the linear pair theorem and the vertical angles theorem, because we have a few sets of linear pairs here. So looking at this first one, I know that these angles right here form a linear pair because together they make a straight line, or these could be considered opposite rays. So DA would be one ray, DB would be another ray. So together these must equal 180. So I could set up a little equation if I wanted to. I could say x plus 116 is equal to 180. And then I could solve for that angle measurement by subtracting 116 from both sides. And that's going to leave us with x is equal to 64. So this is a 64-degree angle. And then once we know two of the angles, it becomes fairly simple. We can use our vertical angles theorem to say that, well, this angle over here, 63, is going to be congruent, or 64 is going to be congruent to this angle over here. So it'll also be 64 degrees. And this angle, 116, is going to be congruent to this angle over here. So this one's 116. So this is a handy little thing that we'll use quite a bit whenever we have two intersecting lines. If we know one of those angle measurements, we'll be able to find all of them. Now we're going to go ahead and do some algebra problems that relate to these different angle relationships. So we have two angles here, angle ABD and BDE. They are supplementary, so we need to remember supplementary, what that means. That gives us a lot of information. That means they're going to add to 180 degrees. And we want to find the measures of both of these angles. Now, each of these angle measurements are given as an algebraic expression. So rather than a specific number, we know an expression that represents their angle measurement. So we'll be using that. So supplementary angles would say that the measure of angle ABD plus the measure of angle BDE, those have to equal 180 degrees, right? That's kind of the basic idea that we'll use in setting up this equation. Well, since we know the measure of ABD in terms of an algebraic expression, we can use that. And we know the measure of angle BDE in terms of an algebraic expression, so we can also use that. And they have to equal 180. Now, this becomes a very simple algebraic equation. We just need to start combining like terms and solving for the value of x. So combining like terms here, I have 15x, negative 12 and 48 will give us 36. And then it just becomes a matter of solving this. So I'll go ahead and finish this off. Feel free to pause at any time if you want to kind of work ahead and be able to check your work with mine. All right, so 180 minus 36. So minus 30 is 150, 144. And then when I divide that, 144 divided by 15. So grab my calculator here. 144 divided by 15, I get 9.6. All right, so now that's great. I solved for the value of x. It's not quite the finished result that I'm looking for. I want to find the actual measurement of both angles. When I'm asked to find the measure, usually that means to find it in degrees, right? So I'm not going to be using these. I'm not going to say that this is the answer and this is the answer. What I want to do is actually find the degree measurement that these would represent. So the measure of angle ABD is equal to 12x minus 12. So that's 12 times 9.6 minus 12. And I'll go ahead and calculate this really quickly. 12 times 9.6 minus 12 is 103 degrees, so 103.2 degrees. So that's the measurement of angle ABD. And I'm going to go ahead and plug it into the other one, but since I know one of the measurements, I could just simply use our supplementary relationship to figure it out. I could figure out what the supplement of this was, and that's going to need to match that. But I'm going to go ahead and use the expression just to make sure that everything worked out the way that we had hoped. So that's going to be 3x plus 48. So that's 3 times 9.6 plus 48. So multiplying that out, 3 times 9.6, 3 times 9 plus 48. All right, and I get 76.8 degrees. So that's the measure of angle BDE. And that is the final answer that we're looking for. We could go ahead and verify that those are supplementary, that they do add to 180, which they do in this case. So awesome. All right, and we're moving on. We'll do another one of these types of problems. All right, so here we go. We have measure of angle ABD is, or sorry, angle ABD and angle BDC are complementary. So we need to remember what that means, right? Complementary means that they add to 90 degrees. Find the measures of both angles. All right, so similarly, we have some algebraic expressions that represent the angle measurements here. I'm going to skip a step a little bit. I'm going to do it quickly. So basically what we're saying is that these two measurements, measure of angle ABD plus measure of angle BDC, equals 90 degrees, right? Again, that's complementary. We need to pay specific attention to whether we're talking about complementary or supplementary. That's going to make a fairly large difference in our final answer. So in this case, we're adding a 90. Right? Now I need to substitute in the algebraic expressions that represent our different measurements. So this one is 4y plus 5. And this one is 4y plus 8. Those are going to add together to equal 90 degrees. And now it becomes a matter of solving again. So feel free to pause it and do this on your own, or just check your answer with what I get. All right, 90 minus 13 is going to be 77. And then dividing by 8. So 77 divided by 8. We're getting 9.625. So again, we solve for the variable, which is great. It's not the answer yet, though. We want to make sure to substitute that back in here and find the measures. Because when we say find the measures, what we're talking about is we're talking about in degrees. So we actually want to figure that out. So measure of angle ABD is 4 times 9.625 plus 5. 4 times 9.625 plus 5. So I'm getting 43.5 degrees for my first measurement. And the second one, BDC, is 4 times 9.625 plus 8, which is 46.5. And so these are our two angle measures that we were looking for right there. And we could quickly sort of check to make sure those do actually add up to 90, which they do. All right. And keep moving on here and doing some more examples of different types of problems involving these angle relationships. Feel free to pause and go back if you need to. All right, now we have these word problems involving complementary and supplementary angles. So an angle measures 4 times its complement. Find the measure of the angle and its complement. Okay, so we have a bit of a word problem here. I'm going to create a let statement to create some variables. So I'm going to say, oops. I'm going to say let x equal our angle. And then we remember from before that if x is our angle measurement, then 90 minus x is going to equal the complement. So I have my angle, technically the measurement of my angle, and then 90 minus x is going to be my complement. So now I need to investigate this statement here and figure out what's the relationship between them. So an angle measures 4 times its complement. Okay, that's pretty easy. That means that my angle measurement is equal to 4 times the complement. Cool, and this is my complement, this is my angle, 4 times the complement is my angle. There we go, this just becomes a matter of solving this. So I'm going to put x equals 360 minus 4x. I'm going to go ahead and get all my x's together on the left side, so I'll get rid of them over here. I'll add 4x. And so I end up with 5x equals 360. And go ahead and divide that, 360 divided by 5. And I get 72. So x equals 72 degrees. So my angle is going to equal 72 degrees. And then the complement is going to equal 90 minus 72, which is 18 degrees. And so there we go. We were able to figure out the angle and its complement. All right. Feel free to pause or go back if you need to. All right, and then our last word problem here, a little bit more complicated relationship, but we're going to solve it really similarly. An angle measures 6 degrees more than 8 times its supplement. Find the measure of the angle and its supplement. So really similarly, I'm going to create a let statement. So I'm going to let x equal the angle measure. And then we know from before, a supplement of an angle is going to be 180 minus x. That's going to be our supplement. Defining my variables at the beginning, or my variable at the beginning, and anything else I'll need is really important. It lets me interpret this as an equation a little bit more easily. All right, an angle measures 6 degrees more. 6 degrees more. That means I'm going to be doing plus 6 than 8 times its supplement. So 8 times its supplement would be 8 times 180 minus x. Okay, so I'm kind of reading this and figuring out what's going on there. So an angle measures, that means that our angle is equal to this, 6 degrees more than 8 times its supplement. So 6 degrees more than this, that means I'm going to be adding 6 to that. So that's what I'll have. I'll have 8 times my supplement and adding 6 onto that. And so this equation should represent this relationship. Now it just becomes a matter of actually figuring this out. So 8 times 180, that's going to be 360, 720, 1440. A large one, minus 8x plus 6. All right, I'm going to combine like terms, and I'll also get rid of this minus 8x. So I'll add 8x to both sides. So I end up with 9x equals 1446 when I add those two together. And now I need to divide by 9. All right, so let me go ahead and do that. 1446 divided by 9 is, that's going to be 160.6 repeating. And the supplement is going to be, so that's my angle. My angle is going to be 160.6 repeating degrees, and the supplement is going to be 180 minus that. So when I do that, I get 19.3 repeating. I could round this to some value. I could just call this, this approximately equal to 160.7 degrees, and then this one would be approximately 19.3 degrees. That might be more useful for us to express our answer as a rounded decimal, or we could use fractions as well, right? Another way to represent 0.6 repeating would be 2/3. So this could be 160 and 2/3 of a degree. And this would be exact, maybe more preferable to have the exact answer over our rounded decimal. And similarly, this would be 19 and 1/3 degree. Doesn't really matter for this purpose. These are good enough. The fractional answers are good enough. The repeating decimal bar is good enough. It doesn't tell us specifically which one is wanted here, but any of them would be fine. All right, and that's the end of this lesson for right now. Hopefully this makes sense. Go ahead and try the homework problems and email me if you have any questions.